Oh, hello. Okay, cool. We're going to start in 1 minute. So if everyone could take a seat, that'd be great. Thank you very much. We're going to start in 1 minute. So if everyone could take a seat, that'd be great. And if you're a presenter, if you could come to the front, that would be super helpful. Thank you. We're going to start in a couple of minutes. We're about to start in 1 minute. Thank you very much. It's been also pretty cold recently, so thank you guys for coming today. All right. Okay. Cool. I'll just wait for everyone to take a seat. Cool. Okay. Well, let's start. Thank you all so much for coming today. My name is Tom Nakata. I'm the co-founder and CEO of Qlay, the guy on the left. We host these events on a couple-week basis, maybe once or twice a month, and it's called AI Talks at Qlay. And what this is basically we invite people who are doing exciting things in San Francisco and Silicon Valley and have them give a talk of what they're working on. Today we have James Lee, who's the head of developer experience at TwelveLabs. There are startups building foundation models for multimodal video understanding. We also have Lewis, co-founder, CTO of Pipelex. They're building the AI workflow language for agents and mere humans. And then we also have Nitya from Peppr AI. They're from YC W25, so that should be an exciting talk as well. Before we jump into the actual content of the talks, I just want to quickly introduce myself and the company as well today. So just bear with me for a couple of minutes. So we're called Qlay. We're the hosts of the event, and we're a startup that works out of this office. And we essentially help other startups hire engineers and get their development up and running. I'm the co-founder and CEO. Before founding Qlay, I was at McKinsey. I was doing a lot of organization stuff. My co-founder Toku is right there, is handling the live streaming. So you guys are being watched today. What we do is we use AI to automate a lot of sourcing and screening of engineers whenever you hire your next engineer on your behalf. And we're working on this product and service because whenever people tend to hire engineers, they go for Upwork and Fiverr. And what happens is you still have to interview and make all of the new coding tests, which you can't do when you're busy as a startup founder. So we do that on your behalf, and we don't charge a recruiting fee. That's how the business model works. And we do this by leveraging a lot of AI as a recruiter agent to do a lot of vetting and find out who the best match is for your position. We also have another co-host today. It's called Open Network Lab. They're an accelerator. They run the accelerator twice a year. They invest around $100,000 for every startup. The equity they take is a lot more reasonable than other existing accelerator, and it's totally up for negotiation. So that's another resource that could be helpful for you. If you want to get connected to anyone from Open Network Lab, just talk to me or Toku during the networking after the talks. We also have a lot of upcoming events. We do these a lot. I guess just to quickly give you a preview of what we're hosting on July 27th, we're doing like a hacker event with the folks at Manus, and then on July 28th, this is in Palo Alto, but we're inviting partners and investors from different VCs to do a startup pitch night down in Palo Alto. So if you're interested in that, please sign up and apply to pitch at the event. I think we invite somewhere from 7 to 8 to 10 startups every event. And then we're also hosting an August 5th, this is down in Sunnyvale at Plug and Play Tech Center. This is more a little leaning towards enterprise. So we're actually, this speaker TBA, this is an AI product person at McDonald's, and he's gonna talk about what kind of enterprise AI integration is happening at non-tech giants. We also have an AI product manager from CVS, so that'd be an interesting enterprise integration. And then another AI product manager from Pete's Coffee. So it's kind of a cool way to know how non-tech large companies are integrating AI. And I think in addition to this, we might also have someone coming from PG&E. So that might be a really interesting one, although I wouldn't know how to deal with that one. It's an interesting topic. And then on August 18th, we're doing another AI talks with folks from Apple, Amazon Prime Video, and another AI startup. So please feel free to go to Luma/Qlay or something like that and sign up for our upcoming events. Last slide, this is kind of a campaign that we do at our every event, and it's where you book a demo call with us at Qlay.ai, QLY.ai. We'll give you a heavy discount, which amounts to around 400 engineering hours for free. So if you're looking for like a trial, working with different engineers and getting things done, and just want to see how we work, feel free to book a demo with us, and we'll let you know how things work. Cool. Okay, enough for me talking. I would like to introduce the first speaker, which is James Lee, Head of Development Experience at TwelveLabs. James, are you good? Okay, cool. Do you want to connect your laptop first? Yeah, this is it. I'm just gonna make sure things work. Do you have another one or? Let me make sure that it's on. Oh, all good. Okay, cool. Everyone, please give a round of applause to James. Thank you very much.
Thanks, Tom, for the introduction. Super excited to be here. And yeah, like the problem that he mentioned about hiring engineers, I think like we also experiencing. So like, great to have platform like Qlay to support with distributed work, right? By finding high quality experienced engineers to support building cutting edge models. So yeah, the title of my talk today is Video Intelligence is Going Agentic. And essentially, I want to talk about kind of how we're bridging the gap between like video understanding and then agentic workflow. So let's start with kind of our thesis on why TwelveLabs exists. So we focus on video understanding, and the reason we do that is because this slide shows how there is increasing growth, right, of video content. By the end of this year, like more than 85–90% of the world's data are going to be video. And besides the data, I think from a just like philosophical level, I think like video is everyone's first language, right? Like as a child, we grow up, we understand the world, we try to think about how we interact with the world, right? Which is essentially like video, right? You're not thinking in terms of words, right? So our hypothesis as a company is like we can represent the world via video, right? One of the issue with the way our existing technology to tackle that is, right now the infrastructure we build to interact with video content is quite brittle, right? So most of the solution before, maybe pre-2020, 2019, is focusing on building, bespoke computer vision model to essentially generate tags, metadata from video content. The issue with this approach is that the tag, the metadata is quite inconsistent, label intensive, right? You basically get an object like a person, right? Activities, things happening inside the video, and they don't really provide enough meaningful context for a lot of the business use cases. All right, like if you try to perform a complex search query like the one I saw here in the slide, then you can not really find anything because you only have the concept of a bow or concept of like, a receiver, but not the entire context of that action, right? And so treating video like image and text, but essentially leaves out a lot of the, nuance associated with video content, right? You get very generic concept. Yeah, be a bit louder, yeah, for sure. There are other, companies that try to essentially applying language model to picking at every single frames of video, and this approach also is not like entirely scalable on all like performance, because if you think about processing every single frame inside a video, then it's going to be extremely expensive and not scalable, right? And also like, you cannot really capture the temporal dynamics or the action objects that moving through time, right? If you only look at every single sequence of every single frame. So that's kind of like my part, which is like if we only look at using CV or LLMs to tackle video understanding, then you try to squeeze the video format into the concept of text or image, and just it's not like a good fit, right? So TwelveLabs as a company, we've been around for about 4.5 years now, and as Tom explained, we build multimodal foundation models. So we got these two foundation models. First one is called Marengo. This is a video embedding model that essentially take in input as your video content and would generate like multi-vector embeddings, right, from the video, which essentially can enable downstream tasks like semantic video search, anomaly detection, interesting data curation workflow, right, across like text, image, audio inside the video itself. And then we also have the second video called Pegasus, which is a video language model. So the idea here is you can like take video as an input and it can generate text as an output. So these texts can include summary, chapters, highlight, description about you can ask questions about what's happening inside the video, right? So together, these two models working together to enable different activities, different downstream tasks, right? That we have a lot of developers and enterprise use to create. Well then, since the title of my talk is focused on agentic workflow, I want to take a step back from focus on video and looking a bit into the agent ecosystem, right? So a lot of these two, I think, as a developer, you're probably familiar with, right? They essentially, like about 1.5 years ago, we've seen the evolvement of like the language model ecosystem going from static model into interactive, agent that can understand your objectives, that can plan actions, reflect on mistake. Some of the more well-known solutions include, LangGraph, LangIndex, Qlay AI, Ladder, OpenAI Agent SDK, right? A lot of these two essentially are frameworks that enable like Asian engineers to leverage the infrastructure, and then they let developers to implement specific capabilities ranging from planning to views, managing memory, and self-reflection, which is ability of the agent to remember what they did and improve, reduce hallucination, right? And then from like the design of the system, they come up with very specific design patterns, right, on how to be a good agent, right? Things like breaking down the task into subsequent step, right? Recursive reasoning, so to improve the ability to remember things and reason better. Leveraging different tools to augment the capabilities through different API call, and then human in the loop is essentially like incorporating like user feedback, right, into the pattern, so that the user have more of a contribution to the way like the output is. So one of the insights I want to show is that like if this pattern is working for agentic workflow in language model, then it can probably work as well for video content, right? If we have like the same, or at least we did it in the correct playbook, right? So we've been looking at the academic field on implementing video agents, and here are just some examples of academic papers from different university and research lab that looking at how we can build effective video agents, right? So on the left side we have Agent, which is I believe was built from Tsinghua University in Taiwan, and essentially it's a system that can come up with an interesting architecture that combine multimodal retrieval augmented generation with a device concord reasoning approach, right? And then on the top right is a paper from Stanford that essentially try to leverage different search and aggregation techniques of relevant information from the video, and then basically only looking at relevant scenes inside the video to gather information from entire lengthy video. And then on the bottom right is a solution called Lavi, which focus on the task of video editing. So they combine language model reasoning capabilities with video editing tools so that you can have natural language editing, right? So these are all like pretty cool inspiration for TwelveLabs as we think about how to build a true video agent, right? And I think that the key thing that we've learned is like we need to build something that can reason across different time frames, right? Going from frames to scene to storyboard, entire story, and you need to integrate like vision, audio, and language all at the same latent space, same workflow. So last year we open sourced a framework called Jockey, TR Jockey, and we also wrote a blog post about it. And we've been doubling down building this application this year so far. Essentially, we call it a video agent framework designed from the ground up for this new paradigm. If you're familiar with the way Agentic workflow works, there's like the planner, instructor, worker designed for a specific task, right? And the way we design this system is we have our specific API models that focus on like a very specific task, right? So if you want to do search, then you can use our Marengo model. If you want to do like video summarization, then you're going to use the Pegasus box over there. And then for any complex video editing workflow, we leverage an open source library called FFmpeg, which is very powerful for trimming clips, concatenating clips together. Essentially, it's the same framework that enable a lot of the video editing tools to operate under the hood, right? And together, like if we decide so that like as a developer you can just specify the task you want to do, and the agent will like execute the task correctly, right? So for the next few slides, I want to talk about the engineering aspect of building Jockey, and then I can show you a quick demo of how it looks like at the current state. So for the developer audience, if this one might be interesting, which is like how do we bring what we call agent transparency, right, to the front end. So agent, most people think it's like a black box system, right? How do we incorporate like UI design so that like end user can know exactly what's going on at the hood. So and for us, I think like because we deal with video processing pipeline, that's even harder, right? Because video processing is actually there's a lot of different steps going in between, from like cutting clips to like figuring out the exact frame rate level. So trying to figure out like how to display that on the front end is pretty interesting. So when our engineer try to design this function dispatcher that can essentially, for every single discrete step during the pipeline, it just like independently handle that, and then it expose this specific like processing stage to the front end, and we just call it like agent thinking mode. Like if you let's say Perplexity, for instance, you probably see like the return from the output, search output on the front end. It display all the thinking steps that go in between. So I think we try to follow the same UI design paradigm. And the goal here, like if we shown everything on the front end, then if from an end user, if you want to come back and edit the query or integrate certain activities action on, and it's much easier, right? Like for the end user to do that, because everything is transparent and everything is modular and developer extensible. These are some quick screenshot of the previous MVP of Jockey. So essentially, we build it in a way that there's the chat interface on the left side, and then there's the we call it the video canvas, video gallery on the right side, and it combines both text and video interface together. And the rationale behind this is like obviously like because we work with video, then a single chat interface is not going to be enough, right? If you want to like manipulate and interact with the video content, and on the other hand, if you only leverage video canvas, then it's just like any other video editing tools in the market, right? You cannot really leverage the power of like language model and agentic capabilities. So being inspired by a lot of tools in the market, right, from cloud artifacts to OpenAI Canvas to like cursor agent mode, for instance. Then you have this kind of like how do we have chat interface in combination, right, with kind of multimodal gallery where folks can understand and interact directly with the video content. Yeah. Diving a bit deeper into kind of the how do we display it to the front end, right? Then here is like some screenshot of how we try to showcase the flow of information between text and visual element. So the screenshot on the left side, right? Like I asked this the question like, find me some TED Talks on AI and robotics that explore the future of human-robot interaction. So what happened is we have this model called Agents Thinking that display all the concrete steps that Jockey came through, and then it displayed the step alongside the timestamp video segment, right? Which help user understanding not just what content was found, but why it was selected, right? So you can like, actually click into some of these video segment and play it back, right? And this is important because it helps you to specify your intent via language query, but also like interact directly with the visual elements of the video. And then on the right side, the query here is please summarize this video in an emotional tone. So we have both the video sitting next to the summary of the video itself, and it, essentially video is a complex modalities to represent. So this way we have the text go hand in hand with the video, which reduce cognitive load, allows you to digest, the video content better. So it's like a small like UI design that allows you to maintain context, right? So I go into the demo right now, and then I go back to the my slide real quick. So this is an example of a Jockey interface. So I'm currently plugged into our company demo account, and you can see that there's a bunch of like what we call indexes on the top left of the model. An index is essentially like a collection of video. So for this example, I'm working with masterclass content, so which is essentially like, you're very familiar with masterclass, just a bunch of shares of the teachers, advertising the content, right? So let's try this clip, right? So this is the clip where you send it to Jockey. Oops. Yeah. Yeah. So you can see here, these are the output that it just returned, and I can actually play it. Yeah. 3 clips of Gordon Ramsay. Yeah, and if you click into the thinking box right here, you can see the process that the agent did to come up with the search result is actually planning the idea. It convert my intention of finding this clip into like a specific API that call a model. After this, beyond semantic search, you can actually do something like please edit these clips into a single highlight. Yeah, so now the agent will detect my intention to quickly combine the clips, edit them together. So you can see here, I just quickly created 20-second clips. So what it does is it just essentially like it just concatenate all the 3 clips that satisfy, from the first step into a single highlight reel, right? This is the pretty basic, like, FMPEG operation, but then we try to think about how to make this editing process more polished. Maybe you want to add transition, you want to drag and drop order of the clips being represented here. So we do have some plans to build that out in the future. And then one final thing that you can do is you can chat with the video, right? So it's pretty straightforward. So you drag the video into the chat box like this. Vertical contour, okay. And then you just, let's say, summarize these clips in 3 paragraphs. Yeah. So now jockey entering chat mode, which is essentially trigger our video language model Pegasus. And you can see the output here. Essentially, it just iterates to entire 3 video calling our API, and you can see the output, right? Like all 3 video now have 3 paragraphs summarization. For example, like this 1 minute masterclass session, the radical counter from Kim Scott, right? Like she, yeah, you can read through the text here, and you can actually watch the video to verify. You know. Yeah, so this is a pretty, effective way for folks who just wanna get a quick understanding of their video content, right? So we have users who just do this for filtering step where they wanna, they don't wanna watch the video content, they just wanna get some quick analysis about what this video is about, right? And then after that, they find a scene that they want, and then they did some more complex editing, highlight generation workflow. The cool thing with the agent is you can actually switch context from one index to the other. So let's say I want to jump into another index that my team is working on. So let's go with, let's see, a lot of sport content here. Warner Brothers, for instance. We're working with Warner Brothers for some projects. So these are all like, television and movies content, right? So 5 clips of Joker, right? The reason I know this is gonna work because I can see the Joker clips right here. Yeah. Yeah, but this is the clip from the Batman. For some reason, it's not playing right now. Yeah, but you got the idea. And now I can like drag the clips and chat with the entire new index, new video, right? And I have the context from the masterclass index, as I did in the past. So I think, yeah, this is a quick demo of Jockey and how we think about building it. Just a nice way for you to chat with your video content, do more complex editing, and we can start thinking about like what are the use cases that folks can do with video content, right? Just have like few more slides left, and then I stop for the next speaker to present. Talking about like some of our enterprise customer. So we have one customer specifically called MLOps, which is the Toronto Maple Sport League Entertainment. They essentially the entertainment company behind the Raptors, the what's the hockey team? I forgot the name. Yeah. So entertainment company behind a lot of the sport, and they quickly use our agent to generate personal highlight reels in 9 minutes, which is actually go from 16 hours. So that's how much time the editing team did in the past to like create these cool highlight reels, right? That post on Instagram. And quantify that is like 98% efficiency in highlight creation, right? So this is definitely like a very great, nice number and nice use cases for us to talk about like how you can use like agentic workflow, right, to improve your enterprise efficiency, right? And as our company evolve, we constantly thinking about like what's next for Agentic interface, what's next for how we build this Choquel framework, right? So a couple of principles that we've been thinking a lot about, and a lot of this is actually inspired by some of the AI tool in the market, like Cloud Code or Cursor, if you developers, right? For example, so flow aware trajectories, right? So what if like this video editing agent can anticipate, like your next asset, your next like highlight creation, and then automatically generate the potential highlights for you to look at it and operate on those assets, right? So this is gonna work very well if like Choquel have the ability to remember like your previous action and pre-assemble rough cuts, right? That aligns with your editing patterns, for example. Contextual meta learning is another one. So this is essentially means that what if the agent can have memory capabilities and then remember exactly your patterns, your desired behavior when you work with video content, like your preferences, your style and pacing, and this will create a virtuous cycles where the agent can become more valuable over time, remembering your requirements, adapting your feedback, right? And finally, just like multimodal scale, right? So like instead of just video and text, uploading audio, MP3 file, like images, right, to the agent, and then it can generate net new asset. So this is the part where I think like TwelveLabs as a company, we can integrate a lot with like some of the Gen AI tools in the market, like on like Runway, Luma Labs, Katisha, 11 Labs, right? A lot of these like partners, I guess, that we can integrate from an API point of view to make like the entire platform better and serve some more creative use case. Yeah, so that's my talk, and I have this QR code, which is essentially would take you to like a type form. If you're interested about trying out Choquel just based on my talk, you can fill out this waitlist form, and I can get you guys do a live demo to you guys, and you can become a private alpha user. And to be very clear, like this is not a publicly GA product yet. This is like a like a YC product that we're building internally, right? So we're just looking for design partners and early adopters who can give us like great feedback on how to build it. As we think about our company moving forward. Yeah. Thanks everyone for learning.
Maybe 2 questions.
Yeah.
Okay, maybe we'll take 2 questions. You can take the first one.
So I'm really curious to follow up a little bit on the memory part. I edit like an industrial number of podcasts, and I have the same exact 6 workflows for every one of my edits. Can you speak a little bit towards your plans around memory in and beyond the 2 slides that you showed?
Yeah, for sure. So I think like there's 2 ways to tackle that problem from the product design and engineering point of view. Number 1 is actually data ingestion, right? So as you as you did your editing right directly on a platform, how can the agent capture that action and store that in some like database, right? Like even the actual like, I mean, you probably see like operator like Manus, for example, they remember your actions, right? So if we can like remember your editing patterns and store that content in some structured database, then that can become context, right, for the video agent to remember and perform the action next time. Yeah, so data ingestion as well, like in general, like and I guess another ideas can be like our model can become better, right? So like as I mentioned, the Pegasus and Miracle model, they are specialized in embeddings and video to text generation. Internally, we also think about can we be like a video reasoning model, right? What is the equivalent of DeepSeek R1 and O1, but for video content, right? So if we can do that, then this video reasoning system can actually intelligently, like I guess predict actions and step, right, for the end user to tackle, right, without the need for a bespoke tool use, right? So I guess a combination of both model capabilities and like tool use could be could help solve your question. Yeah.
Maybe we'll take one more. Okay, cool.
your question is about license data? Hmm? Yeah, so we like our aspiring vision is to understand any type of content, right? That's why we be foundation model, right? Like we try to understand generic video concept, right? I'd say like right now, as a company and kind of our research focused team, we perform better in domain like entertainment, sports, news broadcasting, content creator, advertising, security. Yeah, so those are the domain where we have a lot of training data, and we have customers who like help us with like those efforts. And there are some niche domain that we have developers and startup come to us before in the past, and things like healthcare, things like gaming, things like security. These are like more interesting. Or to your point, industrial manufacturing, robotics, right? These are some of the more I guess like harder problem to solve from a video understanding point of view. So to solve that, I think there's like two main ways, right? We can just collect more data from the field, from customer, to get to be a better base model. And the second thing is actually fine-tuning capabilities, right? So like we do work with selected customer for fine-tuning, where they provide us with like small sample set, right? And then we perform like few short learning, for example, to so that the fine-tuned model can get a better performance, right? On that specific amount of video content. And then over time, it will like, if we work like one or two healthcare customer, over time it will start learning more generic concept about like healthcare domain, and hopefully it will become better in more healthcare video in general. Yeah. Yeah. All right. Thank you so much.
Cool. All right. Thank you. Please give a round of applause to James. All right. Louis, would you be able to we'll grab that? All right. Please give a round of applause to Louis.
Thank you. Hi, everyone, and thank you, Qlay, for having me as a speaker tonight. This is I'm here for a few days, actually, in SF until August 10th. So if you like this talk, you want to learn more later tonight or in a few days, or know someone that should meet me, feel free to contact me, and you have my email at the end. So I'm going to talk about the gap between AI agents and AI workflows. So there are kind of rough definitions, because the sense of all these words has changed a lot for the past 3 years. So I'm just going to clarify what I'm talking about. Maybe you want to agree with the definition, but at least we can speak on common ground. And I'm going to talk about the gap and the bridge. So I love AI agents, and I think the main reason why we love AI agents are that they can do a large piece of work instead of just taking a small question on a chatbot and answering in 20 seconds. They can do large amount of work. Like deep research is a good example, and coding agents are also a very good example of what we know really works. They can act in the real world through tools and the MCP protocol. And they can solve new problems, and I think this is a very particular part of it, because this is where they show what we can do with intelligence. There was a proof of that a couple of days ago when the Math Olympiads, they got a gold medal at OpenAI within an experimental model that shows that we can solve new problems. That's very important. And the way they do that is by coming up with plans, because you cannot guess the solution to hard problems. You have to work on it and think about it. Now, about AI workflows, they're called also deterministic workflows, or someone will call them agentic workflows, or some people will say this is not an agent because it's deterministic. Okay, but the good thing is that these kind of workflows, they can be really reliable, and you can get predictable outputs. You can have them do the same thing every time. They are also kind of like software. I'll come to the details about how to make them like software, but the idea is that like software, we want them to be versionable, to know if we got a new version, if a version is buggy, and if you need an upgrade. And they can be tested, they can be measured, so they can be optimized. I'll talk about that a bit. And one of the optimization, of course, is cost efficiency. If it's a repeatable task, you can run it several times and find a way to do it cheaper and better. Those also can be shared and reused. When you get an agent to do something once, you can share the result, but it doesn't enable you to share the method. And that's where the difference becomes very important. In the real world, there are tasks where you need an agent to do something really new, like you would need someone working for you to get something done, and you don't know how to do it, but you're telling him, just do it, find a way, make it happen. But in the real world, there are also in companies lots of cases where you want the same job to be done thousands of times, and you want it done the same way. They're called processes, and it can be simple methods you give, or requirements like every week I want a report of what happened, and I want it to done like this and like that, and I want it, with the same information in it, and you want it repeatable. If you have something really repeatable like that, it's becoming like software. It's like a function, like calling a piece of software, and you know what it's going to do. You've been able to test it, and so you get it done every time. And we know that agents can use software via tools or via MCP. So there's a place there for collaboration. And instead of saying one is good and the other is bad, and you recognize some cases you need the openness of agents, and in some cases you need the reliability, repeatability of workflows. How can you work with both together? So what if agents could design AI workflow for you? And what if agents could run AI workflows like tools? First one, if AI workflow is like software, we know that we like it when our agents are writing software for us. So could they write the AI workflows? And if the AI workflows are meant to be repeatable, can we have them repeated by agents when they need them, or can we just run them like software? And this begs the question, where is the workflow? Where is it materialized? How do we know? How can we hold it? Is it material? Is it something? Is it a file? Is the workflow a file? And what format is this file? Is it a standard format? Is it compatible? Is this workflow compatible with this or that platform? So that's the bridge we need. And we need an AI workflow language. That is my thesis. And we need there are some non-negotiable parts about that. The first one, it needs to be a declarative language, because those AI models we're using under the hood in these AI workflows, they can do a lot of stuff and a lot of new stuff in new ways every week. So you need to have some stability. And the stability is in the requirement where someone said, I want the workflow to do this. I want it to read the contract and extract all this information and make those analyses. So declarative language is where you say what it does, not how it does it. And some good examples are SQL. I think it's the most known example of a declarative language. You can have any database behind SQL, and it's supposedly doing the same thing. So it also needs to be an open standard to avoid the vendor lock-in, because if you need to translate your workflows from one platform to another, well, it's like in the 60s when every brand of computer had their own language. You couldn't get anything done, and you were stuck to the ground. So open standard is the right way. And it needs to be agent native, and that's what we have in our heart at Pipelex from the beginning. When we started the company, we knew that any tool you build, you have to imagine that AI is going to use it. And now it's become more and more real with standards like MCP. So our AI workflow language needs to be built for humans and agents. Humans are very important here. I talk not so much about human in the loop. I talk mostly about client in the loop. the one that knows what he wants to do, the one that is always right, because he's the one calling the shots. So we need a kind of AI workflow language like that. And now I'm going to tell you more about Pipelex and how we tackle this project. So first, an example. These are some bits of our language. They're solving an actual use case in the real world. This is how we built it, actually. We solved problems for companies, and I told my engineering team to not write a single line of code that would be specific to the use case or the client. So all the code had to be generic, and so all the specific stuff had to be somewhere else. And we tidied it up, and it became this language. And we found out by doing it that the language of knowledge work it depends on each domain. There's always different words in different domains. And so you need to know what you're talking about when you give it to another human, but even more so when you give it to an LLM. So we have created all those possibilities to declare the domain knowledge, the glossary of the words that you're using in this context. Here we're in the context of processing expense reports and making decisions for refund and stuff like that. So another important thing is structure. Here we have different fields in an expense, and we have different possible values, and all of that is what makes things clear, deterministic, and reliable. And here I have just one example of what we call a pipe LLM. Our workflows are called pipelines, and they're using sequences of pipes or pipes that can be run in parallel or apply rules and conditionals. But this is just an example of a pipe LLM call, which looks mostly like its prompt, but there is also the definition of the input concept and the output concept, which are the ones which are defined over there. So this is a conceptual language. The abstraction layer is that of the use case it is solving. And so here are the main points. Level of abstraction, I just said it's conceptual, the vocabulary of the business, of the domain, and of the use case you're solving. We're focusing our pipelines on sequences of pipes, and we're focusing on this pattern, knowledge in, knowledge out. So we're not doing workflows that can do anything. We're just transforming information, but it can be in different sorts. It could be a PDF, it could be a photo, it could be some text, it could be a video, anything that all those AI models can take in, we can manage. And but each pipe is knowledge in, knowledge out. So when you assemble them, you get something bigger, which is knowledge in, knowledge out, which means that these pipes can be composed in sequence, they can perform batches, conditional rules, and a pipeline can call another pipeline. This is not a feature we added on top of it. This is really the base of it. So we got also another aspect, which is the hierarchy of solving a problem. When you solve a huge problem, you're maybe solving 5 sub-problems, which are solving 5 sub-problems each. And this is stuff that can be shared around different pipelines that you can work on different days, or different people in the team, different company, different teams, and all the community can share what they solve so that you can build on these shoulders of giants. Other important stuff, as I told you, each pipe can use a different AI model. So we're not using only LLM. We have also, of course, vision. We've already integrated with OCR and image generation, and we're going to add a lot of stuff soon. Our pipes can generate structured outputs, which means the data is typed, and the enumerated values are applied and checked and validated. For those of you who code in Python, where we're using base models, Pydantic base models, that can do validation. And this is a major point that makes our pipelines usable like software. They can extract information and put it in a database, and it's validated even before it reaches the database. It can be the answer to a function. It can be the input to something else. So they also compose like Legos with meaning. I told you the language is conceptual, and the concepts are defined. So it's telling you what it wants as input and what it's going to give you as output. So if it doesn't work, it can check itself why it didn't work. It's checking conceptual typing. And so it can look at your pipeline and tell you if it makes sense. And if something went wrong, it can detect automatically what went wrong. For instance, if you had an input which was a non-compete clause in a contract, for instance, and you actually got the address instead of hallucinating the result, the pipeline could just debug itself by saying, there's a problem, dude. I wanted a non-compete clause and you sent me an address. This is not going to work. This is also, as I show you in the examples of the language, you see that the workflow logic and the prompts and the definitions, they're all in the same files. So that makes it very consistent. And that enables agents to easily read that and also write that because they have all the information right there. And so they can also test and debug and optimize cost reliability and help you in writing those pipelines. So I have a demo. I don't think I will have the time to show you the whole complete video. It's less than 5 minutes, but I want time for questions. But the title of the video is this, From Whiteboard to AI Workflow in Less Than 5 Minutes with No Hands. So this is really what we're doing here. I don't know if it's going to play. I think if I click here, yeah.
Hi Louis.
Hey Thomas.
We are Pipelex, and we're going to show you how to convert this whiteboard into an AI workflow in less than 5 minutes with no hands. Feel free to drop your use case in the comments below.
So I'm going to show you a couple of screenshots so you understand, and you can watch the video. It's on YouTube. We just gave the picture, the actual picture from the whiteboard, and we dropped it in the cursor agent here, and told it to create a pipeline from the provided whiteboard using Pipelex. And then it wrote the Python structures for the expense report concepts. All of the code generated by cursor was for Python definition of the models, the data models, and validation. It also created the definitions of the concepts. So what I showed you earlier, the thing about you need to define all the concepts is not a chore for humans. You know, you get AIs to do it, and then you get your domain expert to review it and maybe add, do some fixes and add some details. So this is what it looked like. It started with a PDF extraction with a PypeOCR and then a PipeLLM. And funny enough, the cursor agent who had taken our photo as input actually recreated the requirement workflow right there. So, and this is, I wanted to show, this is the pipe sequence, which is simply stating we take an input, the OCR PDF, we output a refund decision, which is a structured object, and here the sequence of pipes is going to execute. What is funny here is categorized articles. It's a batch over articles, which means that when we extracted several articles from the expense report, we're going to treat them one by one, which is very important for reliability. So other point about this works because we gave the agent tools to validate the pipeline. And that's what it did. So it fixed its own bugs, and at the end it validated, and it did a dry run with fake data and fake LLM calls. So it costs 0 tokens, but you can check the logic of the workflow this way. And so this was the result. This is a structured object with the decision taken about each of the articles, and you see you have information which is structured. This is a date time, this is an amount, and you have all this can be used and processed in your ERP or in any other process down the line. It could be used in other workflows systems like N8N or Make, of course, and it could be used with any agent thanks to the MCP server we are preparing. When it ran, it recorded what happened during the execution of the workflow, and so at the end you get generated a flow chart of exactly what happened. So this is where you see that there was a list of articles, and it managed to process each article separately. So here it is. If you want to reach me, this is my email. As I told you, I'm here for 3 more weeks. Do you have any questions?
Maybe we'll take 1 or 2 questions. All good? Okay, cool. All right, please give it up for Louis. Thank you so much.
Yeah. Let me add that it's open source, so you can find the repo on GitHub, and you can try it. And if you like it, give us a star. Thank you.
Thank you. You can just leave the mic there. All right. Okay, cool. Last but not least, we have Nitya Arora, founder of Peppr AI, and they're a YC W25 company, and they're a self-improving knowledge base synthesizing scattered company data. Everyone, please give it up for Nitya. All right.
Hi, sorry. Yeah, as Tom said, I'm Nitya, one of the co-founders of Peppr AI. We went through YC in the winter batch, so started in December, ended in March. What we're doing is we're building an org-wide brain that understands exactly what's going on in team and employee workflows, so we're able to map and auto-document all of the technical IP, key decisions, and moves that are being made in a company. So when someone leaves or when people forget things, you're not relying on human memory, you're relying on a proactive memory layer that's constantly changing and dynamic in your company. So that kind of brings me to the first point of this talk, which is what we realized internally was that context is the new velocity. So in an age where, you know, foundational models are being put out left, right, and center, what we were able to pick up on was really, especially in companies today, human intelligence is the moat. It's the next talent that you're bringing in, the people that understand your existing workflows, the people that are making changes to your product that make customers happy. And all of those changes and decisions are strewn between meeting notes, Confluence docs, poorly written documentation, and weird ideas that you have on Slack threads. And so what we did was we went into each of these tools, Slack threads, meeting notes, Teams, your Otter AI conversations, and we started to auto-document and connect and create a narrative around what's going on in each of these sources and how they relate to one another. So my co-founder and I we worked at NVIDIA right before we went to YC, and what we realized working at NVIDIA was, for myself at least, I was a computer vision engineer, and I'd spend at least 4 hours every Friday creating one update email that would go to all of my managers and 100 other people at the organization to try and explain what I had done that week. I'd spend like an average of 80 hours a week just working, debugging, understanding, you know, simulation software that was built by an entirely different team that I needed to integrate into my own workflow. And what I realized was no one was reading those emails. And no one knew what I was doing at the end of the day, even though I spent 4 hours trying to write it down. And aside from that, I spent 60% of my time just talking to people, trying to explain what I was doing and trying to learn from them and from their tribal knowledge and their effort that they put, you know, 3 years into building new tech and understanding, you know, how that simulation software works. And so we realized that all of this work we did was absolutely worthless, especially when we left. So when my co-founder and I left NVIDIA, no one knew what we did. And because of that, we created Peppr because we realized that this isn't a problem with dev workflows or with team size or with specs. It's actually just a problem with documenting information properly and in a way that it can be made actionable in the future. So that brings me to how organizations today lose time and speed to just memory. So most organizations and engineering teams will focus their effort on building solutions and not writing clear documentation, as they should. Your goal as an engineer or as a product manager isn't necessarily to be writing specs all day, it's to be making the core decisions that actually move your company forward. So for an AI world, that isn't as optimal because AI requires context to be able to operate. And in the future that we're looking at today, in the next 2 to 3 years, we're trying to hand as much of the leverage of being able to help make decisions to AI as possible. We're trying to mobilize AI agents that are going to help us make decisions, help create change in our orgs. And in order to do that, they need to be able to think like us. They need to be able to know what we're thinking, know what we've actually contributed. What that looks like is, in an ideal world, we'd have update memos every 3 to 6 weeks for every project, and engineers would document work as they go, not just at the end, and reviews would happen with full written context and not just slide decks that are pieced together with PDFs and images that are strewn together and thrown into like a Slack thread. But that's the world we live in today. And so in a world like that, you can never really expect engineers to onboard in hours instead of weeks, or leadership to understand what's going on in the company all the time, or critical work to not get lost in Slack threads or Jira tickets and hallway conversations. And companies today don't really have time to build this playbook for AI, to actually prep themselves to be able to use AI properly. And so what happens without this context is when devs leave, no one knows where things stand. Infra decisions are continuously repeated. You're wasting time doing the same thing 3 or 4 times just because people don't remember how it was done. And incidents continue to occur because historical postmortems about how something should have been done or how something shouldn't have been done to perform and to full capacity and not repeat errors are buried in old conversations. And so instead of asking why did we do this or how did we do this, our questions should now be how do we move forward? And that's where we're bridging the gap. We're trying to build a proactive memory layer that is able to answer all of those questions for you. So what this looks like is the previous approach to even using AI tooling within companies is passive. It relies on being waiting to be asked what is going wrong or what happened in a workflow. It relies on summarizing or searching existing content and then being able to find what's going on. And it requires human initiation. Whereas in the world we live in today, we're able to orchestrate context proactively, which means we're able to capture knowledge from work in progress. The entire MCP wave has shown us that context is the next layer of being able to empower AI agents. And so building that layer of understanding what people are working on and how they're doing, that's the first primary infrastructure that you have to create so that you can even mobilize agents that are able to understand what's happening in a computer vision engineering workflow or an Oracle software engineering workflow. And what this does is it helps us create structured artifacts of why we're making decisions, when people are making decisions, and who are making those decisions. So leaders aren't waiting to figure out when a problem is going to happen. They can instead just be told how it's happening, what's happening, and they can create and make decisions faster in order to solve those problems in the first place. So like I said, our solution at Peppr AI kind of drawn from all of this experience that we've had, like creating change in enterprises and being frustrated with how slow that innovation can be, is being able to auto-document all of these decisions in real time, being able to connect to Slack, GitHub, Notion, Linear, and capturing work across all of these platforms, and then being able to spin up what looks like an actual real-time personal digital twin with your context that's able to help you and not be instructed by you in order to create the next code fix or push the next commit. If you've seen how Cursor or Windsurf or any other AI tools work today, they're heavily based on human prompting. And the truth is that we don't even know how to use these AI tools properly today. We're still struggling with being able to prompt the right way, being able to prompt efficiently, knowing how to actually instruct these tools to work with the context and within the boundaries and limits that we have. And so building this context layer is the key to unlocking how efficient AI can be at organizations. Whereas if you operate with a tool like Cursor that doesn't have full context of your org yet, you're going to be unlocking only about 20 to 30% of its potential, while it could be operating at about 90% with full-formed context that allows it to understand what knowledge to operate on and how to operate off of it. And the third thing we're doing is moving from a reactive model of using AI tools to proactively nudging and understanding what's going on in your workflow. So that means taking decisions that lack context today and being able to show you blockers instantly and show you, a Sev 1 as soon as a commit is pushed that could cause that in the next 3 days. So overall, if there's one thing that I'm sure you've heard me repeat throughout this talk is that context is very, very key to every move that we're making within Agentic AI, whether it's in the enterprise like Peppr is focusing on, or just in our individual workflows. And the good part is that we no longer have to rely on ourselves or our human memory to be able to prompt and use these systems. All of this can actually be very well written and structured in context that we can pass to these tools so that they can be leveraged to help us better and replace the gaps in our workflows instead of increasing them and almost widening the gap between what we need in our organizations and how we get there. Thank you. Just feel free to ask. Yep, go ahead.
The information you need is amongst a group of people. And so is there some concept that you guys have which is a collection of twins?
Yeah. So I can actually show you really quickly. So this is our interface. It doesn't look that good when it's pulled up on a full screen like that. But if you go to view over here, you're able to, like I said, we've dissected it down to every individual employee workflow, but then you're also able to combine different employees' intelligence. So I can create like an infra plus growth pod over here, which has 3 team members, has myself and my 2 founding engineers. And you're able to see in real time these proactive insights about what's going on in these workflows. I'm gonna zoom in so you see. But you can imagine these change every day. So there's a prompt in there that understands and personalizes to what you want to see, what's important for you to see in your role, and is able to show you like what needs attention. So this auth fallback issue, for example, is something that Tanush resolved a blocker for, and now the SDK work is back on track, so I should probably go back in and check on that pod and see how that progress is going. If you imagine managing like 1,000 people, this tool becomes instantly very useful because now you're able to look and proactively interact with the context of this combined intelligence of 3 people that are probably working on something you haven't touched for like years. Yeah, go on. Yep.
The first one being, it seems like, is there a reason why you're focusing on engineering teams and not like the whole organization? Because it seems like the problem is like company-wide, like every department will have these same challenges. I'm just kind of curious your thoughts around that. Second question is, in person, like teams where you're actually working in office, how do you capture the stuff that's not entered into these tools? So like just conversations that are happening, decisions being made in real time.
Yeah, so those are 2 really good questions. For the first question, yes, we don't really just focus on engineering. I kind of thought, I mean, that's the first use case we started off with. As like co-founders, we're both from a technical background. When we started this company, we were thinking about engineers and how, I mean, across most org functions, engineers are the most well documented, I'd say. Like there's a lot of processes that, I mean, there's code to look at, like you can see exactly what they've done. So it was an easy starting point for us. But today we work with sales orgs, we work with HR orgs to, run performance management pipelines, auto reporting across every org function. We even run a lot of, sorry about that, my computer's old. We even run like cross-functional collaboration between teams, so sales teams asking technical questions to digital twins. That's a very important use case for us. And then to your second question, it is very hard to obviously capture in-person conversations. And the way that we try to fill that gap is our system proactively asks you to document certain things based on what it can see in your existing workflow and what gaps are there. So let's say it sees a code commit and it's like confused. It's like, I don't really know much about this, or there hasn't been a lot of conversation about this in Slack. That's probably something you've been talking about in person. It'll proactively ask you in Slack to be like, it'll ask you a question, it'll be like, hey, what was this code commit about? Just write a quick snippet, and then it adds that to the memory layer. Go on.
Okay, so you're reading the commits, or you're reading the code and the documentation in the code, and are you like updating the cursor rules based on the changes in the code and the documentation and all the stuff we have to deal with today?
Yeah, so that's actually, those are, I mean, the last two things you mentioned are things we're pushing. We have been shipping this past week. So we've gotten quite a bit of demand for that.
Awesome.
Yeah, go ahead.
I think this is really cool. I also feel like one good like use case would be if someone goes on PTO, like you can ask them
Exactly, yeah.
questions. A question that I had is if it has access to like all your conversations, is there a way to like filter out like sensitive data?
Yeah. So integrating is pretty easy with us. So basically an admin will go in and configure the platform integrations. What we do change, or what we do differently is kind of permissions aware. It's a completely permissions aware system. So a lot of tools aren't able to support this today, which is something that has made us a little more competitive. It's just being able to inherit all of the context from Slack that only you're able to see. And let's say I spin up a digital twin of myself, only the context that you're allowed to see from my Slack chats. So we build a system that's completely permissions aware like that across every tool. So it inherits the sets of context that should be accessed from Slack and then from Bitbucket, from GitHub, from all those different tools, and only operates on that set. Great. All right. Well, thank you.
Oh yeah. Go for it.
Do want any more information, feel free to connect with me on LinkedIn. I'd love to chat. And then our website is usepeppr.ai. So feel free to take a look at that if you'd like to. Thank you.
All right. Thank you so much, Nitya. One last thing before we close it and go back into networking. It would be great if we could take a quick picture with the speakers. So James and Louis, if you could come up, and then if we could take a quick picture with the audience, that'd be great. Ethan, do you want to take it? Thank you. James, can you come up? Then maybe we can face that way. Louis, you're very safe.
Yeah.
Toku, do you want to do it?
Yeah, sure.
Oh, you can just put it on. All right. Thank you so much, guys. Feel free to grab drinks and leftover pizzas. Bring them home if they're still there. All right. Thank you so much, and I'll see you guys in a couple weeks.
Thank you. Yeah, I'm sorry. I was like a little unresponsive.
No,
We've
that's
just been doing
fine.
so many deployments the past few